So these are two of the most synonymously used words on the internet, or should I say the World Wide Web. Let's find out the difference between these two in this video. To understand the World Wide Web, you must first understand Internet. If you look up the definition of Internet on Wikipedia, it describes it as the Internet is a global system of interconnected computer networks that uses the Internet Protocol suite to communicate between networks and devices. It is a network of networks. So the definition on Wikipedia describes Internet as a network of networks. Let's expand into that idea and see what do they mean by networks of networks. Let's take an example of an environment where two or more devices are connected to each other such that they form a network. A similar network exists at a different geographical location and they are connected using a cable. Then there exists a network that consists of more than one device located at different geographical location to communicate with each other. And if we expand that cable to a separate network located at a different geographical location, then our network has expanded even more. And if we keep expanding the cable to networks at various geographical locations until each device is able to communicate to another device located at remotely different location, then we have created a network so large that we can call it the internet. This is the internet in a nutshell. However, it is much more complex when it comes to communication between devices. So let's start our discussion with the basic building block of the internet. That is a network. So a network is when one or more computers are connected to each other using a medium such as a cable to allow data sharing. The medium of the connection between them can be both wired and wireless. Once they are connected to each other, they can transfer files, stream videos, play games, and so forth. The number of devices in a network can be a minimum of 2, but any number of devices can be connected to a single network. A similar example of network is when two mobile devices are connected to each other wirelessly using Bluetooth to transfer data between each other, where one device acts as a sender and the other a receiver, and both of them can communicate and send files to each other. A network can be classified into different types based on their size, shape, and type of devices used. It can be a local area network, a metropolitan area network, or a wide area network. Local area network, depending on its size, is smaller compared to a metropolitan area network, and similarly, a metropolitan area network is smaller in size from a wide area network. So let's discuss each of them in detail. A local area network is confined to a relatively small area. It is generally limited to a geographic area such as your home, an office, a school, university, or a hospital. Depending on the size of an office, it can be expanded to multiple campuses. For example, a university or a school containing campuses inside a city at different locations. So a network between multiple campuses can be considered a local area network. Now, if we combine all these and we expand our network to the whole city, we can call that a metropolitan area network. And expanding that network to multiple cities can also be called a metropolitan area network. Now, metropolitan area network compared to local area network is larger in size because it is connecting multiple cities together. Now, if we combine multiple cities and expand our network to different countries and we connect each country together, then we create a wide area network. Now, considering each type of network building upon the other until every continent is connected to the other continent using cables such as fiber optic cable or more recent technologies such as satellites. The physical connectivity between the computer devices, or we can say a large network that is comprised of networks, is basically called the internet. Since we have just discussed the physical connectivity of computer devices, the question arises, how do these devices communicate with each other in a network? The answer is IP, or more specifically called an Internet Protocol. An IP governs the communication in a network. Since it is a protocol, it specifies some rules that has to be followed when communicating over a network, one of which is the unique addressing scheme. In a network, there needs to be a way to differentiate between different computers, routers, and websites. IP addresses provide a way of doing so and form an essential part of how the internet works. Every device in a network is assigned a unique identifier called the IP address, which allow other devices to send information to that specific device over the network. The IP address contains the location information and make devices accessible for communication. So let's take a simple analogy of a mail. To send a letter to a particular address, the letter must contain a unique address of the originator and the destination. The destination address must be unique so that the letter ends up at the correct destination. Once the letter is initiated from the source, it reaches the post office and then it is sorted and dispatched to the correct destination. Using the same analogy in terms of computers, every device is assigned a unique number to allow communication and data sharing between them. Let's talk about how an IP is represented. So an IP is represented as a number between 0 and 255. They are expressed as a decimal notation. The minimum IP is 0.0.0.0 and a maximum number is 255.255.255.255. There are other examples as well of a valid IP address. It can be a 192.168.10.50, a 157.240.10.174. So these are some of the valid IP addresses that can be assigned to a computer in a network. Then there are some special addresses that serves a unique purpose in a network, and they contain some special information about a device in a network. There are a lot of other details about an IP, such as they are divided into different classes. There is something called IPv6. There are some special addresses, reserved addresses, and host ID and a network ID. That's how the inner workings of IP functions. Since we have just discussed, we can assign a unique address to a computer in a network so that they can communicate with each other. Now, these unique IP addresses are assigned to every device in a network, even a home router. So the question is, who assigns them? The unique IP addresses are assigned to us by someone called an ISP or the Internet Service Provider. Depending on your locality, various Internet Service Providers will be operating and providing Internet services in your area. You can subscribe to one of their Internet packages and they'll install a router at your home, connecting you to the rest of the Internet. Since Internet is such a large network of devices, it is difficult for every device to connect to every other device. Therefore, ISPs make it easier for you. The Internet architecture is a complex design. It is a mix of different devices such as servers, routers, switches that are connected through both wired using copper cables, fiber optic cables, etc., and wirelessly using radio waves, satellite, etc. That is why Internet is mostly represented as a cloud of all these devices interacting with each other to make communication possible all around the globe. One such type of device that we are interested in is called a server, and this would define the foundation of the World Wide Web, as we'll discuss in this video. When thinking about servers, one could imagine a large room containing these mysterious devices working in mysterious ways to make the internet possible. However, it is much more simpler if you understand what these devices are and what they do. Server is just another computer with better hardware than the one you are having at home. With more processing power, storage, and speed, they have an overall higher performance than a personal computer. They run a specialized operating system, which makes them suitable for running programs that are specifically built for servers. So what type of programs do they run? The one that provides services to the user. So you may ask, what type of services do a server provide? It can be a file server so that users can upload and download files from the server. It can be a database server where users can store their data and retrieve them at a later time. It can be a multiplayer game server where multiple users from different locations connect with each other and play a game. Or it can be a web server. And there are other types of servers such as a print server or a fax servers and so forth. The one we are interested in right now is a web server. A web server is the one that serves web pages, or you can call them websites. To access any website, you must remember the name of the website. Then using your favorite web browser, you can type in the name of the website in the browser, and the browser will send a request to a specific server. The web server will process the request and send back some files in a response, which your browser will process and then display a beautiful website. We'll discuss about these files in later section. For now, they are a bunch of HTML, CSS, and JavaScript files. So all of that communication happens in the background while you type the name of the website in the address bar and wait for the website to load. So what is Google.com? What does the name represent? So far, we have discussed that all the communication in a network occurs if we know the IP address of the device, or in this case, the web server. We are using a name rather than an IP address to access a web server. This is all just to make it easier for users to remember their favorite website. In reality, when sending a request using a web browser, the web browser locates the IP address of the server using the name you just provided and serves the web pages to your computer. So, how do we find the IP of any website? The answer is DNS, or more specifically called a domain name system. Just like a contact in your phone book, the DNS translates the name of the websites to IP addresses, so browsers can load a web page and communicate with the web server. DNS server eliminates the need for humans to memorize IP addresses. For the web browser, DNS lookup occurs behind the scenes and requires no interaction from the user's computer apart from the initial request. So let's see how it actually works. Before your browser sends a request to the web server, it sends a request to something called a DNS server. Your browser will send a request for google.com to the DNS server, and just like a phone book, the DNS server will look up for google.com in its directory. Once it finds google.com, it will send back the IP address of google.com to our web browser, and once our browser have located the IP address of google.com's web server, it can easily contact the web server by sending a request, and the web server will process the request and send back the HTML, CSS and JavaScript file to our web browser, and it will display a web page. So you may ask, where does our browser find the DNS server? And the answer is simple. When you request a connection from your internet service provider, they will configure a default DNS server on your home router, and you do not have to worry about most of the communication that occurs on the internet. The internet service provider will allow all the communication between you and the web server without you knowing how the communication occurred. And similarly, as your internet service provider connects you to the Google web server, it allows you to communicate with other servers and other websites such as Instagram, Twitter, or any website that you may remember. The internet service provider will hide all the complex communication occurring behind the scenes and will make it easier for you to connect to the internet and surf the World Wide Web. So far, we have described what the internet is and how it works. As the internet lays down the physical infrastructure for communication of devices, the World Wide Web allows users to access, share, and create documents. And not just documents, users can share videos, audios, and other web resources. As we have just discussed, this is possible using web servers. World Wide Web is a place where anyone can host a website and share documents across the globe. Each website has a unique domain name and may contain one or more web pages that are linked to each other using something called hyperlinks. A single website can have hyperlinks to itself, or it can create hyperlinks to other websites. An interesting example is of Google's search engine. One can use a search engine to search for a particular term on the World Wide Web, and the search engine will display a million websites relating to that particular search term. This is an example of how a website references other websites, and it is possible because these documents are referenced and stored for ease of retrieval. On the web, there are millions of websites with billions of web pages containing different documents that are referencing each other to create a web-like structure. That is the reason it is called the World Wide Web. Let's talk about some history of the World Wide Web. Starting from 1993, the birth year of World Wide Web. The web during the time is also referred as read-only web. The reason is the documents created on the web during that time were simply static web pages. That is, there were limited or no user interactivity possible. The web only allowed readers to retrieve information from websites. The websites only feature static text and images. Web 2.0 is more relatable to the web of current era, which is also in transition to Web 3.0. Web 2.0 allows lots of user interactivity, allows user to create content and share it across the web. The web pages are dynamic and full of user-generated contents, such as Wikipedias, videos, podcasts, microblogging, social networking, and more. Web 3.0 is the future of web, and the current generation will experience the transition from Web 2.0 to Web 3.0 as time goes on. We have already experienced some technologies such as decentralized applications and non-fungible tokens over the blockchain while they are being developed and improved. Semantic web is the automation of information retrieval. It allows computer programs to deduce and reason over the information extracted from the web and provide contextual and meaningful results. There are these technologies like virtual reality and augmented reality creating a virtual space for user interaction, giving rise to a ton of new applications in gaming, virtual exploration, education, healthcare, and much more. Then there is Internet of Things that provide a possibility to connect every device to the internet, such as traffic lights, car, buses, home appliances, and more, allowing them to communicate automatically without human interaction and creating smart cities and smart homes. Cloud computing allows consumers to store data, perform computation over the internet rather than using their own local resources. Each of these technologies are currently in constant development and improving with time. Each topic deserves a separate video. We'll leave that to the future. Summarizing everything we have described in this video. So internet is the physical infrastructure, while the World Wide Web is a service running over the internet. Internet allows communication between devices connected through wire or wirelessly, while the World Wide Web provides access to web pages, documents served on a server. Internet uses number of protocols including the TCP/IP protocol, while the World Wide Web uses HTTP to communicate between server and client. That's it for this video. For the next video, we'll be discussing the World Wide Web component. Stay tuned, take care, and goodbye.